Okay, so the section we're in section 1.1, and I'm gonna mix 1.2 today because 1.2 only has like one new concept that we have to talk about. So section 1.1 to 1.2, we'll kind of go into 1.2 probably more tomorrow. I thought we were gonna get homework today. I think we're gonna just do, we'll get tomorrow and we do like later next week. Just because I don't want to get too far ahead of the other class. If I give you guys homework, they don't get it until tomorrow anyway. So, but we're still graphing. The big thing about today is there's three main things I want to make sure. Number one, can we do a substitution correctly? So I'm going to explain that. That's a part of graphing. It's where they give you a domain, and you have to graph a function. That's the word domain we've seen before, but I want to make sure that you actually understand that word completely. And that's where substitutions, we're going to graph those. Next thing we're going to talk about is the table one more time to make sure that you understand how to graph that. If they ask you to graph like the data from a table, I don't know if we did that yesterday necessarily, but I want to do one where we do a table. And then the last thing I want to talk about today, which is kind of new, is domain and range. So, domain and range versus range. And this is a topic that I think the only time we've actually discussed it up till now is when we did viewing windows. But today we're going to actually talk about how to write that. And there's a couple different ways of doing it. It's called set notation versus interval. And I introduced that concept in the first prerequisite chapter. But today now we have to put it into practice, which is way more difficult than you think it is. So today is like the intro day, so don't feel overwhelmed by it. Okay, so that's kind of our outline, rough outline of what we're going to do today. But let's start with the first one. Make sure you have your graph paper, please. So have your graph paper. Here's what I like to do. We're going to go f of x squared plus, let's just go x squared plus 3. Okay, and down below, this is what the book is going to give you. They're going to give you this. X equals, in curly braces, -2, -1, 0, 1, 2, and 3. That's what they give you.
So we write that on the graph.
Okay, so yeah, so this will be like, you want to write this like off to the side or something, whatever you're going to do. What they're doing is they're going to ask you to graph this function, right? But instead of just giving you a free-for-all, they actually tell you, hey, you need to graph these specific numbers. That's it. You're not going to connect them with a line or a solid line or like a curve or anything like that, because you're only graphing, what, 6 numbers? That's it, 6 numbers, not an infinite amount of numbers, 6. So you're just going to put dots on the graph. Don't connect them because we're not doing all the decimals in between them. If that makes sense. Because if you connect with lines, I do have to count it wrong because you're graphing way more than I asked you to. So, so the first one, when they give you this set, you're going to take each of these numbers one at a time, plug it into this function, and then we're going to go graph it. I need to pull the graph here. I thought I had it, but I guess I didn't. All right. If I had it open, I guess I must have closed it last night. All right. Perfect. Okay, so there's my graph. So we're gonna plug in a -2 first. What's -2 squared?
4.
4. Add 3. 7. So when we plugged in a -2, we got an answer of 7 out of that thing, right? Go plot that point. So -2 times 7. 1, 2, 3, 4, 5, 6, 7. There you go. Just put a dot there. Make sure the dot is easy to see. I don't want it to be so small that I have to pull out a microscope to like kind of look at. It should be a pretty decent sized dot, but don't overspill into the other boxes around it. So, you guys can see it's a marker, but somebody sitting next to you should be able to see that where you're sitting without having to lean over too far. Okay, next one, -1. What do we have? -1 squared. 1. Add 3.
4.
4. So -1, 4. Okay, keep going. What's the next one? 0. Okay, plug in 0, what do we get? 3. Okay, now you're starting to see it is starting to curve. It isn't a straight line, there's actually a little bit of a curve there, but we're not connecting this with lines. Remember, don't do that on this problem. Plug in the number 1. What do we get? 4. 1/4. 1/4 out. Now you're starting to see what this thing is starting to look like. Next, we're going to plug in a 2. And we get 7 again. 7. We plug in the 3. 3 squared is 9, plus 3 is 12. So 3 times 12. There you go. That's what you have to do. That's your first few problems you're going to have tomorrow on that assignment, where they give you the set numbers you need to go plot. Go put the dots on the graph, don't connect them, that's it. It's pretty straightforward. Now the thing is, they're gonna give you the formula. So that, like in that problem, the directions will have this. They'll say, for the following problems 17 through 20, use this domain, use the domain provided. So that's your domain in the directions. And then problem number 17, this is what it would say in the book. That's like what it would have on the paper. So you'd have to, okay, look at the formula, use the numbers they have up above in the directions, and then just plot them. Don't draw lines, anything. Does that make sense? Pretty straightforward, pretty easy, right? It's not a free-for-all. You only have to plot the set points that they have. I think on the test you have for chapter 1, I think that's the very first problem that you have. It's like that style of problem. Because I want to see, can you plot, can you actually graph, and can you write down the coordinates correctly and stuff. Okay, so again, the domain are the x numbers you're provided, so that's what they're kind of trying to explain to you. Okay. All right, let's go to the next style problem. Let's go to a table. We did a table yesterday. We did a table like this, where they had 3 different sets. My goal today is I'm just going to put some random numbers in here just so you can see this. -2, -1, 0, 1, 5. Okay, so here's your table. I'm just kind of making up the numbers for it. Trick is, when we're going through this, is to answer the series of questions they're going to ask. So the first question we did like yesterday is like, they give you like 4 or 5 different options, and they say, hey, which formula matches with y number 2? Like what equation represents function y2? This one. So they'll give you your options, you have to go figure out what it is and how they got to it. So whatever the formulas are, they give you something that you can use to go find it. So maybe you just plug the numbers into the formula and see if it actually spits out. These are the numbers you're plugging in, because these are 3 individual formulas. Okay, that's the concept. Okay, so it's pretty straightforward. You plug in all the x's, you see which one matches. Now you guys don't have a graphing calculator like I did yesterday, where you could like type in all your functions and hit enter, and you can see the tables and kind of compare them to see which ones match. But that's the first question. I think we did that enough yesterday. We did them for the 3 different ones we have. But today I want to get to those secondary questions. Where does y1 equal y2? So that would be like the secondary questions. So where would y1 equal y2?
-2.
-2, yeah. So this one right here, this coordinate at -2, x equals -2, the y numbers turned out to be the same digit. So you could write it like this, at x equals -2, you could write it with the coordinate, like this is where they matched. You could write it, x equals -2, y equals 4, that type of thing. But I'm looking for something where you acknowledge what the coordinates were. Does that make sense? Like you're trying to figure out where they actually crossed. Did they intersect again later? Like y1 and y2. Doesn't look like it. From the table, it doesn't look like they matched. You went -1, 6, -1, 8. No, those don't match. And you're kind of looking for the they overlap again. It doesn't look like it. So there's one intersection point. This is where they intersected. They crossed somehow. Okay, whatever the formulas are. Okay, so that's the first one. Second one. y3, does it pass through the origin? This would be like one of the later questions, one almost the last questions that they asked. Did y3, the function, actually hit the origin?
Yeah.
Yeah, it does, because it actually did hit 0, 0. 0 for the x, 0 for the y. 0, so then all you'd have to put is yes, that it hit there. That's like, it's a yes/no type of question, but it justifies that you can actually see that. Did the other functions hit the origin? No. The other two had y-intercepts. Y-intercepts on the other two, y1, the y-intercept is this one, and then the other one was 0, 12. So they hit different spots. Okay, questions on the types of questions they're going to ask you about tables. The trick about the table, though, is these are coordinates, right? You could actually go plot them, see where these things are going. It's kind of like what we just did over there. Instead of like actually calculating yourselves, they actually just give you the coordinates. But you have to imagine that there are 3 different formulas. So y1, y2, y3 are different, and you have to go like plot them separately. Okay, questions on the table, though. Perfect. All right. The last thing I want to cover today is probably the more difficult stuff. I want to spend most time today on domain and range because it's brand new. I want to intro it today to make sure you kind of know it and feel a little comfortable with it, and then you can understand how it works. Okay. All right. So let's go to your graph, and I'm going to I'm going to put a drawing on my graph, and then I want you to try to mimic it on yours. So try to draw what I'm about to draw, and I'll try to pinpoint where these coordinates are. Okay, so the first coordinate. Let's go -10, +2. Put it out there, -10, +2. Let's put a coordinate at -4, -2. Go 0, -2. Let's go 1, 3. 3, 1, and that should be good. Okay, so now we got our 3 dots. So I'm going to repeat those dots because I'm going to draw a flowing line. I want you to copy this. So -10, 2, -4, -2, 0, -2, 1, 3, and 3, 1. Now here's where I want the lines to go. Okay, so I want the lines to be like this. Do the best you can to mimic what I have drawn. All right, so this graph, this is something we're going into the next section, the next couple ones, next couple sections, where we're going to start interpreting graphs. And they're going to ask you a series of questions. Well, the first one that I want to spend the time on, as opposed to some of the other stuff they're going to have me find, is domain and range of an object. So domain and range, domain are all the x numbers you can use, range is all the y numbers you can use. Okay? So on this graph, as I go from left to right, so I'm kind of like looking from left, and I'm looking to the right. Is there any breaks in the graph? Are there any holes? Nothing. It's like there's arrows too. I mean, it keeps going. That left side is going like horizontal and has the arrows that's going towards -infinity. This right side is going up, towards positive infinity, like it's going up, it's skyrocketing. It's going way up there.
Either send it to me. I want to talk to those kids is what I want to do and make sure they'll come down.
Okay.
So either send it to me or
I'll probably send it to you maybe between the next period.
or take a shot and
Okay.
send it. Okay,
All right.
thank you.
Okay. So next, what we're going to do is we're going to write down what the domain is. So domain on this one. Okay. So on the domain, I want this in what we call interval notation. This is something that we introed back in one of the first sections. but there's two different types of notation. We're going to use interval in this class. And I'm going to explain that again in case you don't remember it. We did interval notation a long time ago when we were doing unions and stuff. We're kind of looking at a very, very distinct style. So what interval notation is, it's when it uses brackets and parentheses and commas to signify where the numbers go. Okay? So this is like one of the most challenging parts. That's why we're going to take our time on it. So I briefly hinted at it back in the first chapter, but now we have to like really understand it because you're going to have to use it quite a bit now. So interval notation, how it works, if they use brackets, that means the number is included. Number is included. So that means that they have solid dots, they're filled in, it's actually like that number's included on the graph, it's being used. If there's open or gaps, you'd use parentheses. If there's arrows on a graph, where you're going towards the left side there's an arrow or the right side there's an arrow, we'll use parentheses. Parentheses. This is anytime you have arrows or the number is not included. So there's like an open circle or there's a gap where like the graph suddenly stopped and started again, we'll use parentheses. And we mix and match these things together to give a sense of where the numbers go. So what we're going to do first is we're doing domain, just domain. And I'm using just X numbers for right now. So what is the lowest X number, if I'm using the X-axis, what's the lowest X number that they're possibly using on this graph? Yeah, negative infinity, right? It's going to the left forever. So it doesn't matter what negative number I pick, that arrow tells me I'm using every negative number to the left. So I'm going towards negative infinity. So that's my lowest number. So you always start with the smallest number possible. So we're going to put the smallest number here. That goes in this spot. This spot is the biggest number that you can possibly use as you go across, unless there's a gap. And then you have to stop at the gaps. Okay? So my smallest number that we had was negative infinity. Well, infinity are arrows, right? That's what an arrow is. It's going towards negative infinity. So this is how we're going to write it. Negative infinity with a comma. That's the lowest number I'm hitting. And notice I used a parenthesis because you don't include infinity. It's not a number, it's a direction. It's an arrow. Now, was there any gaps at all in the graph? There wasn't. So as we keep going from left to right, the biggest number I'm going to be using on this one is in positive infinity. So I'm going to go up to positive infinity this direction. I'm using every X number this way because that arrow keeps going. So I will eventually use every X number. It'll take a while because it's kind of steep, but eventually I will hit every X because they'll be included. So this is what you're looking at right here. This is interval notation for the domain. Lowest number up to the biggest number. Does that somewhat make sense to you? That we're using every X number. The reason why I use this notation, it is the fastest way to show somebody what all the X numbers you're using. Like you're using all of these numbers in this set. And it's not using like sets. I'm not writing like 1, comma 2, comma 3. That's called roster method. That takes too long because I'm using all the decimals too, all the in-betweens. So I can use like -2.5. There's a number there, but I don't need to include that in a roster. This takes care of it. I'm going from here up to this, and the comma separates them. Okay, make sense? All right, that's domain. Now the next picture we're gonna do it where there's gaps. So you can see how do we work it when there's a gap in this problem. Now let's do range now. Range has the same concept. All right, so range. Okay, the range of this problem. The range is going the Y numbers now. The Y numbers. And it's the same concept. If it's included, you use a bracket. If it's an arrow or not included, like open circles, you use the parentheses. So, on this, we're using Y numbers now for the range. So the Y values. What's my lowest Y value I'm hitting? -2. It doesn't go past -2, agreed? Like it was like horizontal right there at -2. So -2 is included. There's a bunch of solid dots there. So what we're going to do, since that's my lowest number and nothing's going past that, we're going to use a bracket and put -2 there. That's my lowest Y number I'm hitting. Now as we go up, is there any gaps as I go up? No, I mean this thing's going up forever. Because if I go up, I know that one's kind of going to the left, but it's still included because this thing bubbles and then kind of goes up forever. There's no stopping. So it's going towards positive infinity on the y-axis. And notice that that's a parenthesis. That's a parenthesis there. Because it didn't stop. It's going to keep going. Do you see the differences? How quick this is? You're going from lowest to biggest number. The trick that most people make mistakes on this stuff is when there's gaps. The gaps really trick people up, like how do you do it, how you're supposed to write it when there's a gap, because there's a definite starting and stopping point. And the second thing is, people forget that you're only using y numbers for range. They try to use x numbers, or they mix them together. So it's like left and right versus up and down kind of thing. Okay, questions on the first one. This is like the easy one to break this in. Here, we're good? All right, now let's get to a tricky one. Let's go to your, what graph you want now? Third graph, fourth graph, something like that?
Fifth.
Fifth graph, okay, good. Let's go to the fifth graph now. Same exact idea. We're gonna do an interval notation. Interval notation for domain and range again, but now there's going to be breaks in the graph and open circles and things going on in this one. Okay, so we're going to start over here. Let's go to -5, -5. Let's go -5, -5, -5. Put a dot there. It's going to go up diagonally 2 blocks and be an open circle. So it's going up and it's going to be an open circle. Then we're going to have a dot, an open circle at -1, 0. It's going to bubble up and come back to 4, 1. And that's going to be a closed circle. And I want to hit a peak of 4. And I want to go past 4 on the y-axis. So it's going from -1, it's going to bubble up, graze like 4 in height. And come back to 4, 1. This is my function. Somehow it's a piecewise function. There's 2 different graphs going on here. One's a curve, one's not. So -5 is a solid dot. -4, -3 was a open circle. Then -1, 0 is an open circle, and it bubbles up to 4 and comes back to 4, 1 with a closed circle. So now this is the part that I want to warn you of that is like the tricky part most people really struggle with, is this part right here. Let me just stop the camera here. Okay, so let's do domain first. So there is a break in the graph. Does everyone agree with that? There is a break. So what we're going to have is that the domain will have 2 separate things. Like there's going to be something written over here. We're going to do a union. And then we're going to write something over here because there's a break in the graph. There's like 2 separate domains going on here. So the union means we're going to add them both together. That's how it works. It's not an intersection, but a union. We're going to add the 2 domains together. So what was the leftmost, the smallest x number that I'm using? -5. Was it a solid dot? Yeah, so -5, put a bracket. We're including -5. There was a solid dot at -5 for the x numbers. As we move to the right, did it stop somewhere?
Yes.
What was that? -3? But was it open or closed circle? Open. So it went up, like as we go left, right, it went to -3. That's an open circle. So we're going to put -3 and put a parenthesis there because you don't include it. It was an open circle, it's not included. We just got to -3, but we're not including it. That's what that's telling me. Then we're going to do a union. Because now there's a break in the graph. That's when you always do unions, when there's a break. Usually if there's an open circle, there's a break there, unless there's overlap. This graph didn't overlap anywhere. And now we're going to start with the next lowest x number, which was, what, -1. That was my next lowest x number. And we're going to go up from there. -1. Do I have a bracket or a parenthesis? Parenthesis, because it's not included. So -1 with a parenthesis. This is not included. And then we went up to what, 4? That's the biggest x number, and that's included, so that's going to have a bracket. There's your domain right there. Questions at all about domain and how to write it when there's a break in the graph? It gets more complicated than this. I'm starting easy and kind of working our way into it. Because it's tricky when there's overlap or there's just an open circle in the middle of the graph, that kind of thing. Okay, what I'd like you to try right now that you have the idea, I'd like you to try to range by yourself. Now that you know the concept, range is going to be the same concept, right? There's going to be a break, you're going to have to do union, all that good stuff. So I'll let you write that down. I'm going to let you try to do range. Okay. All right, somebody have an idea how to do it? So you want to be brave and walk up here? Okay, you want to come up? You want me to turn off the camera or leave it on? Leave it. All right, here we go.
Handsome boy.
This is some good looking pants.
So, we start off with -5, -3, parentheses, union. No. 0, 1.
Okay. Any concerns, comments, changes?
Doesn't it go up to 4? Because it goes.
Does it go up to 4 or 1?
What, are we going up and down?
We're going up and down. 4 or 1, which one?
Oh! Wait. It's gotta be 4, right? Because that's up there and that's up there. Yeah.
4. Okay. Everything you wrote was absolutely correct. He started at -5, thank you.
Oh, yeah.
So -5 up to 3, and 3 was an open circle, so he couldn't include it, because remember, we're going up and down now. So he's absolutely correct, we went up to 3. There was a gap, so we did a union. He started at 0, which is perfect. That's the one that most people make a mistake on. Most people, they forget we're doing y numbers, so they always put -1 here when it's supposed to be 0 on the y-axis. Up to 4, and we included 4 because they said we hit a peak of 4. Okay. These are tricky, when you start getting into it, because most people want to use the dots. They want to use the dots. But sometimes you have to look at where the graph's going, up and down versus right and left. So remember, when you're on range, it's strictly up and down. Don't use the X numbers. That really always throws people off. That was really good though. That was just a little simple thing, because most people want to use the dot. So not bad. Okay, any questions or comments or anything about the intro today? That's a pretty good start today, so that's pretty good. We'll stop there. I know you got some time here today. Yeah, a couple more minutes. But tomorrow, bring your book. We will get our first assignment of the week, I guess, tomorrow. It'll be due next week sometime. It'll be pretty straightforward. I'm not going to send too many tomorrow, because it's homecoming weekend, and I don't want to do that to you, but you still have to get to some homework.
I still need to retake my test.
Yeah, so if you're gonna retake or whatnot, those will be in probably today or tomorrow. Make sure you're coming in and you're trying to review with me for a minimum of 10 minutes.
Hey, Mr. Ward, tomorrow I'm gonna have impulse